I don't know.
Okay, let's recap. Exponential versus log. The graphs. Okay, the basic exponential. So I'm just going to give you an example like this. Y equals 2 to the x is an example of an exponential equation. And it would look something like this.
Like that being a height of 2?
This is the coordinate 0, 1.
1. Okay.
Because the exponent 0 makes a result 1.
So x is just 0.
0, comma 1, 1, comma 2. Okay. There is also another type of exponential. And this looks like this. Zero, comma 1.
No, I was going to, but then I did French and studied which did actually no good for me.
Okay, so they both have the same domain. Would you agree? Domain, negative infinity to infinity.
Yep.
And the range is both the same, 0 to infinity, right? So that's the characteristics of an exponential function. Why is this one going this way versus this one going that way? What's the difference in this scenario? Anybody see what I could say as a common theme here? So this one has a base of 2. So think about life. If something doubles population, what does your population do? If it doubles, 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 it is growth. Yep, increasing, there's growth. If the base is bigger than 1, it's going to grow. It's going to, this one, double, 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 double. So this one is, well, there's a word for it in math. We usually say it decays. It decreases, whatever you want to write there, that's fine. And why is it reducing? It's because the base is less than 1. So think about it. A third tomorrow, a third of what we had, and then a third of what we had. We're getting lower and lower, lower, lower. Okay, characteristics of that versus a log graph.
Is he good? Is he fun?
He's fun. He's adding stuff to me. If we want our power line, if we just want our give our top line layer rest, we put me in orbit and move it around.
Yeah.
Me and orbit just go hands on one. Like we have to guard the star player on.
Well, then it's like a 2v3.
Is it 2 people? It's guarding 2 people. That's fine.
Okay, so here's your typical log graph. 1, comma 0 is on there, and this one would be 5, comma 1. But you can see the characteristics now. This is domain 0 to infinity, range negative infinity to infinity, which is the opposite of that characteristic, right?
Okay, so it goes to 5 because not the exponent.
You'll get that more in my next step. If you don't get it, ask again on the next step.
Or did you learn that yet?
Okay. Okay, we're going to do one quick example. So here's an exponential, here's a log. Okay?
So,
They both have one thing in common. What is the one thing that they both have going on that's the exact same? Base of 3. This one also has a base of 3. So we're going to start the same way. 3 to the negative 1, 3 to the 0, 3 to the 1. Just to get myself a few points, I'm going to start both of them the exact same way. So what happens with a negative exponent again? Flips, so 1/3. Any exponent 0 would produce a 1 and a 3. Okay. Here's the big moment where they split different. This has the coordinate -1, 1/3 versus the log would have a different coordinate 1/3, -1. So here's kind of the understanding. This is exponent, result versus this is result, exponent. Because remember our first day working with logs, we were always having to actually figure out the exponent at the end. That's the output this time. It's your backwards brain. Okay, so this is 0, 1, and this is 1, 0. This is 1, 3, and this would be 3, 1. Okay.
all you have to do is be our teacher so people can make a layout.
So there you go. That's the understanding of exponents versus logs.
I know we're gonna win with you on the team. I'm not even worried.
Do we also understand that we switched x and y? And there's a name for a function that does that specific thing.
Reciprocal. Oh.
No. Close. It was in that
Let's do it, Jesse.
inverse.
Oh, the inverse. Oh, okay.
Inverse, and I think we use that symbol quite often. They're inverses of each other. Do you also remember what physically happens on a graph of an inverse? Do you remember that concept? What's physically happening on a graph?
It's the
It reflects over y equals x. So do you think these graphs do that? Can you see it? If I should have put them on the same graph.
biting your finger.
Thanks,
There. Do you see? Does it look true?
Keeps you unfocused.
The exponent and the log graph, does it look reflected over the diagonal? Because it's an inverse function of each other. We've switched all the x's and y's around with each function. Okay, that's the big picture. Does that make it feel better today?
Well, and people would like that.
Okay,
They'll be like,
so
"Smart,
here-
you're having fun with it." It's just like
here
a
is
boring
the
way.
question that I missed.
I hope we're first year chemistry.
Okay, so this is a new thing.
Or do you actually?
Normally we have been seeing log here. And this is a question I skipped because it's different. Instead of saying log, it says ln, which means natural log. It's the natural logarithmic. So everybody in the French would be a natural log au naturel. That's why maybe the L is before the N. I don't know.
Thanks.
Does that make sense? Log au naturel. Okay. Now we have a new secret math number. You ready? Do you know how this was a secret yesterday? If there was a log With no base written, it was 10. That was a secret.
I got a haircut.
This time,
With the bunnies.
the natural log
You're full of this.
doesn't have a base, and the secret base is...
Secret base.
1.
No one will
Zero.
guess it. No one will guess it. Don't worry about guessing it.
35. 92.
E.
Of course.
None of you will guess it, like I said.
We were not even close.
Oh no.
Frickin'
Who took
knew
my
it.
last calculator?
Uh-oh.
Okay.
What's
I can do
the-
it in my head. Okay, everybody has a E button. Oh, here's my calculator.
Of course you don't get that box.
Everybody has an E button. Okay, do you know in math, if I say pi, that's actually a number, right? 3.14, blah, 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 blah. E is also a number. So everybody's finding their E button. Mine's at the bottom here. E to the X, and I would have to put E to the 1.
I have E to the X and I also have E.
You should, mine is an E to the X button.
Okay, I'll use that.
And then mine gives an exponent, so I have to put E to the 1. And it should be 2.7 da 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 da. Okay, here we go. How do we always start? How do we always start? E to the negative 1, E to the 0, E to the 1. We always start base to the, we do 3 things. Okay, well we just did this, right? We all just did E to the 1. So I'm going to write 2.7. It's a graph, so I can just go to 1 decimal, right? Because on your graph, I'm not going to see the difference between 3 decimal places or 1. E to the 0. Everybody should just know that one without the calculator. 1. And then you can do this one in your calculator by either pushing E to the negative 1, or you could do 1 divided by E. Same thing. Is it 0.4?
0.367.
Yeah, so I'm going to go with just a 0.4 then.
Wouldn't it be 2 negative 2 point? Oh, never mind.
Okay. This is a log equation. So how do I write my coordinate? Do I do it exponent result or result exponent?
Result exponent.
I just rounded 1
Result
decimal.
first.
Result exponent, because it's a log, so you have to do it in the backwards order. 1, 0, 2.7, comma 1. So those are my 3 points. Those would be on my parent graph. Are you okay if we skip that step and just do the final graph?
What do you mean parent graph?
Like if I just graph this before my transformations. I'm just going to skip that step. Okay, what do we have here?
Miami
ABCDs.
versus Denver.
Game 7.
Parties, no parties every game.
Agreed. A
We're going over it.
and a
It's going to be high for you guys.
C. A and a C.
Game 7.
Win whatever you want. That was just so sketchy.
And I'm going to write this. X plus 2 comma negative y. X plus 2 comma negative y, right? There's my C and my A. Okay, so 2.4 comma positive 1. 3 comma still 0. And 4.7 comma negative 1. Okay, let's talk about asymptotes for a second here. On a log graph, where is that asymptote to start with? Like this. Is it still there?
No, it's moved.
It is moved where? To the right 2. So I may as well draw that first. So there's my new asymptote. X equals 2 is my new asymptote. And then my points should make sense with that asymptote, right? So remember that there was a reflection. So does your reflection visually make sense from your original log? Your original log shape. This is always an original log. So did we reflect? Yep.